In order to find the greatest common factor of two or more numbers, it's helpful to understand three concepts. So I'm going to go over these three concepts. One is the factors. So what are factors? The next one is going to be the idea of prime. And the third one is composite. Okay, so factors, these are numbers which multiply into a number. All right, and another way of saying that is they divide evenly from a number. So multiplication, division, remember inverse operations. So factors, these are these numbers that multiply together to make a number, or the factors of a number are those individual numbers which multiply to create that number. All right, so prime, this refers to numbers whose only factors are themselves and we can say 1 too, right? So themselves and 1. All right, and then composite numbers, these are numbers made up of two or more other numbers multiplied together. Okay, so these are the three kind of concepts that will be beneficial to understand before finding the greatest common factor. When we're looking for the greatest common factor, we're going to be, first off, we need to find the prime factorization of the numbers in our pair. So let me give you an example of finding the greatest common factor. And we're going to start off with just two numbers. So let's find the greatest common factor here. Let's look at an example of 24, and we'll do 18. Okay, so 24 and 18. And I want to find what the greatest common factor is. And so to do that, I need to find all the numbers that are prime factors of each of these numbers. So we're going to use make a little factor tree is what they call this. So as we do this, what I'm doing is I'm saying what two numbers multiply to give me 24. And it can be any two numbers that multiply together, any two whole numbers or integers that multiply together to give me 24. It's, you could have picked, you can do 12 and 2. We could do 8 and 3, 6 and 4. 24 and 1 isn't really beneficial here because you still have the 24 to deal with. So let's do, I'm just going to pick one. I'm going to say 8 and 3. Okay, now note this number here is prime. There's no other numbers besides 3 and 1 that multiply to get to 3, so that's prime. So that means I can't break this down anymore. But 8 I can break down. I could do 4 and 2. All right, and 2 now is prime, but 4 it has 2 and 2. Okay, now I have this broken down into its prime factors: 2, 2, 2, and 3. If I multiply these four numbers together, I will get 24. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. Okay. And then I got to do the same here. I got to find its prime factorization. So here I can write this down. 2 times 2 times 2 times 3. Okay. 18. Well, we have 9 and 2. And let's just go with that. 9 and 2. Again, just find one. A 6 and 3 would also work. Let's just stick with 9 and 2. 2. Prime. We're done there. 9. Well, that's going to be 3 and 3. And those are prime. So the prime factorization for this is 3 times 3 times 2. Okay. Now I need to find the greatest common factor. Well, greatest means the largest, and common, what they share together. So the largest factor that they share together, we can use this prime factorization to find that. So we look at factors that can pair up. Well, this has a 2, and there's a 1, 2 over there as well. Okay, and then we have a 3, and there's 1, 3. Okay, now there's a 3 here, but there's no other 3 to pair it up with. Okay, that 3 is already paired up. So all that they share is a factor of 2 and a factor of 3. Great, so that means that in this case, for these two numbers, we can say that the greatest common factor is equal to 2 times 3. It's those two factors together, which is 6. Okay. I'll do one more example here. Finding the greatest common factor. Let's try 35 and 20. Okay. Okay. So I'm going to start again. I'm going to find those prime factorizations. So I make my little factor tree. Well, the factors of 35, or what multiplies together to make 35, is going to be 5 and 7. Well, that's handy because 5 is prime, 7 is prime, so we're done. 20, on the other hand, let's see, that's 5 and 4. We got 5, but 4 can be broken down, so there's a little more work we got to do with 20. All right, now we know, okay, this is 35 is 5 times 7. That's the prime factorization. The prime factorization in 20 is 5 times 2 times 2. So again, let's find our matching factor pairs. Well, 5 and 5, that matches up. That's they pair up. 7, there's no 7s over there, and 2s, there's no 2s over here. So that's it, just 5. That's easy then. You can say then, the greatest common factor, or the biggest number that can multiply evenly into these numbers, or that divides evenly from these numbers, is going to be 5. Boom. All right. So that's greatest common factor there. Now, for some of the homework, you might see some like kind of trick problems. You know, like there might be something like this. You could have 9 and 20. 9 and 20. Well, factors of 9 are 3 and 3. Factors of 20, we already did this. 5 and 4, 2 and 2. Okay, so those are the end of the line there. So notice there's nothing over here that matches up with anything over there. Right? There's no shared factors. So in this case, I'm just going to say, well, the greatest common factor is just going to be 1, because 1 is technically a factor, right? I could say times 1 and it wouldn't change this number, right? Times 1. So they do share 1. So in this case, the greatest common factor would be 1. And you might also see things like this, like 16 and 32. Now, you should be a little careful because I could break this down. It's always good to kind of think about these numbers for a sec before breaking it all down. But if I think about this, 32 is 16 times 2. Well, 16 is technically a factor, right? So we could say, and this will be true, that 16 is a factor of both of these numbers. So the greatest common factor is just going to be 16, which is one of the original two numbers. Now, let's say you didn't recognize that right off the bat. Okay. And that frequently happens where you're not able to immediately recognize what the greatest common factor is, which is why it's helpful to break these down to the prime factorization. Okay, so we can go, well, 16 is 4 times 4, 2 times 2, 2 times 2, so 2 times 2 times 2, and then again, well, 16 here, 4, 4, 2, 2, 2, 2, 2 twos. So we got 2 times 2 times 2 times 2, that's for 16, and then here, 2 times 2 times 2 times 2 times 2, and so now, well, they share a pair of 2's, another pair of 2's, another pair of 2's, and another pair of 2's. And so that's 2 times 2 times 2 times 2, or 2 to the 4th power, which is 16. And so let's say you didn't recognize that 16 was a factor of 32 right off the bat. Well, you can always break this down and you'll get it the right answer, which is one of the cool things about being able to find the prime factorization. I hope this helps.